A 5 kilogram object is completely submerged in a fluid and experiences a buoyant force of 40 newtons. What is the object's apparent weight in the fluid? So if we imagine the situation, we have a container, let's say, like a pool. There's water, that's the surface of the water, and then there's an object, okay? Now, what are the forces acting on this object that's submerged? Well, there's the gravitational force, which is always acting, which is mg, always acting downward. And then there's also a buoyant force, which is, of course, the force of the water, the volume of water that's displaced by the object acting upwards. Okay, so then there's the buoyant force, which is Fb. And they tell us what that is. So if we measure the weight of this object, the apparent weight apparent, right, is simply going to be the sum of these forces, right, where we're going to have, it's going to be equal to its weight, which is the gravitational force, mg, minus then the other force, which is the buoyant force, since it's going in the opposite direction, Fb. So what is the gravitational force? Well, it's going to be 5, that's the mass, multiplied by g, which is the acceleration due to gravity, which is 10 meters per second squared approximately, really 9.8, but that's close enough on the MCAT as 10, right? Minus 40. So this is simply going to be 50 minus 40, which is going to be 10 newtons. So its apparent weight is around 10 or 9 newtons. Now it's 9 because, of course, we rounded up with the gravitational force, so it's going to be a little bit lower than that. But B is the closest to the right answer here.